Today, I'll show you how to install DeepSeek R1 and use it locally with Ollama on a MacBook Pro. You may be familiar with what Ollama is. If you're not, it's a great tool for running local models on any laptop. It works on Macs, PCs, Linux, anything. There are two ways you can download Ollama. You can go to their website and hit that download button in the middle and download and go through the installation, or as I'll show you later, you can also use on a MacBook Homebrew. But before we do that, let's just explore the website a little bit more. You will see that there are GitHub, models, and Discord links. So let's just go ahead and click on the models and explore what models it supports. Right on the home page, you will see that they're advertising DeepSeek R1 support because it's so hot, because everybody is searching for it right now. Ollama put it right there in the middle. You can also go to the models tab, and DeepSeek R1 will be the one at the top. They support models from 1.5 billion all the way up to 670 billion parameters. And you can click on that and explore different options. You can get information, and you can see that these models are based on Llama or Qwen. And from the drop down, you can change the model size, and it will give you the command that you need to run in order to execute this locally. So Ollama makes it super easy to download, manage, and run models locally on any laptop. Let's move on. The second way we can do this is through Homebrew. The command to install Ollama through Homebrew is brew install Ollama, and the easiest way to do this is to go to the website and hit that copy button. Once that's done, open a terminal, paste it, and just wait for the installation to finish. Once it's done, just type Ollama space list to make sure that Ollama is working. And from there on, you can see the models that are installed. I have quite a bit of models. And if you want to run any one of these models, for example, DeepSeek R1, all you need to do is type Ollama space run DeepSeek R1, and then Ollama will respond with the first prompt. If you get to this point, that means you have Ollama working and you have DeepSeek installed locally. All right, let's move on. In this section, we're going to start with a simple question. Let's just ensure that our model is working and see a basic performance. I've used the 7 billion parameter model, and the size of the model is 4.6 gigabytes. And I just want to make sure that it's working okay on my laptop. And as we can see, it's doing just that. You can also choose to download the smaller model. The 1.5 billion will have a better performance on smaller laptops. Or if you have a GPU, of course, going up is a better choice. Now, let's start testing our Ollama installation with DeepSeek R1. And the first question will be about gravity. So let's ask, what is the reason for gravity? And just quickly test the reasoning capabilities of DeepSeek R1. So once we ask that question, you may notice that it starts with a think block. For this, because it's a factual, it doesn't require many steps or breaking down a complex task. There is not much thinking, so it just provides the response. It's a simple question, but it's a good way to test our model. Our next question will be a little bit more involved, and the question will be, what is the relationship between nutrition and athletic performance? And now the model will provide a lot more thinking steps. And as you can see, it's breaking down the task into smaller tasks and then analyzes each task and then comes up with small solutions to these problems. At the end, it's summarizing it into different items that then pertain to the final answer. They will be synthesized to come up with the final answer. And we have a list of 10, the nutrition, the carbohydrates, the protein, the water, macronutrients, micronutrients, recovery, specific needs. This is a phenomenally good answer, and it's on par with some of the better commercial models, as many people have already commented. Let's test it with another question real quick. This time the question is, what are the best ways of getting to Mars in 2025? It's a bit of a tricky question because obviously currently we don't have such an ability, but we'd like to test the boundaries of the model and see its thinking process. And here, between the thinking tags, we can see that the model is starting to break down the task, and then it compiles the knowledge embedded into this model. I should also say that the model date cutoff a year in the past, so it doesn't have the latest and greatest information. For example, if you search for a MacBook Pro, the latest information embedded into the training data was the M2 processor, so it doesn't know about the M3 or M4 processors. Keep that in mind. I'll talk about what are the good ways to test a reasoning model versus a functional model. And now we have our list, how to get to Mars. And as we can see, we have advanced spacecraft technology, faster than light travel concepts. I mean, a lot of these are science fiction material. None of this is currently existing, but still, it's a good way to understand how the model works. Let's go on with another question now. And this time, we're going to ask for a specific question that requires some level of reasoning. And the question is, if fire breaks out in a 12-story building and emergency pathways are blocked, what is the best strategy for survival? So that is the question. And here the model again is breaking down this task, creating blocks of thought. And these thoughts are later chained and solved in a way it's a big puzzle, and the model breaks it down to smaller chunks of puzzles and then solves each small puzzle. So that's a good way to think about it. I have greatly sped up the playback of this video. On a MacBook Pro with M3 processor and 16 gigs of RAM, answer to this question took about 2 to 3 minutes. So in order for this tutorial to be at a reasonable length, I just compressed the time. So what you're seeing here in 20-30 seconds normally took 2 to 3 minutes. So again, experiment with small models or go to a higher model, but for me, the 7 billion parameter model is okay-ish just for testing purposes. We have a list of items and they look reasonably good. Let's move on. Let's ask another question, and this time the question will be a little bit more reasoning related. And the question is, what is the best way to transition from traditional development roles to AI-enabled development? Please list 10 concrete strategies. And here the thinking starts, and the model is exploring different ways of how to transition from traditional development into AI-enabled development. As you can see, there is a great level of detail. In these thinking blocks, the model comes up with all sorts of sources of information and then combines them together. But one thing I would be cautious about is that when you're using this model, the stuff between the think blocks usually is not very useful data because it's a lot of deliberations, and some of those thoughts are not very useful. In fact, some of them are confusing and the model discards them later on. So just take the information that is after the end of the think block. That's the good information. Because these models are text-based, there's no structured way to produce data. You can just use a filtering in Python and just filter out and trim down the response and just get the good part of the data. All right, so we'll have a very good list of items. Understand the shift. It's a really good advice. Acquire new skills. Shift your programming focus. Learn data handling. Collaborate, network, seek mentorship, so on and so forth. So this is an amazingly detailed answer. The DeepSeek R1 performs great when it comes to reasoning and complex tasks broken down. But does it do well with current events or product research? As you may have heard, DeepSeek R1 is unique because it performs greatly and it's on par in terms of performance with some of the commercial models from OpenAI, Anthropic, and Google. But it's also a small and open source model. So it gives anyone, any developer such as myself or potentially you with a small machine, no GPU, no expensive hardware, a way to get into reasoning models. And reasoning models are different than functional models in a couple of aspects. Number one, their ability to do chain of thought and break down complex tasks and apply logic to each one of them and then chain that logic into something very, very cohesive, minimal hallucination, better performance on complex tasks that require lots of thinking. Some of the older models, the GPT-4os, GPT-3 models, they were great at solving atomic problems, small problems, but they were not very well suited for complex multi-step problems, and they were stumbling. So these reasoning models, the new generation reasoning models, it does a phenomenal job in solving these complex problems. But there's some shortcomings. And those are inability to use function tools or produce structured outputs. That's documented on DeepSeek's website, but there are ways around this. And I've made a tutorial about this in particular, and it uses PydanticAI to get the unstructured data produced by DeepSeek R1 and then produce it in a structured format. If you'd like to check out this video, the link will be in the description. If you'd like, you can also check out the GitHub repo where we have many code examples on PydanticAI, small agents, LangGraph, and more. If you need support or just want to connect with like-minded AI developers, consider joining the Discord server at the URL above. The link will also be in the video description. R1 from DeepSeek is a powerful reasoning model that can be used freely in any local setup. The small footprint and high reasoning capabilities of DeepSeek R1 are an ideal choice for everyday use. Ollama provides an excellent way to get started with DeepSeek R1. I hope you've enjoyed this tutorial and you learned something new. If you like this type of content, please consider becoming a member and giving the video a thumbs up. Thank you and see you in the next one.